In this video, we're going to look at a slightly more complicated example of the ratio test. So in this case, we're asked to determine whether the series 2 over 5 plus 2 times 6 over 5 times 8 plus 2 times 6 times 10 over 5 times 8 times 11, and so on, is absolutely convergent, conditionally convergent, or divergent. The first thing we notice here is that all of these terms are positive, so there's not any real worry about conditional convergence because there's nothing here that's alternating or throwing in some negative terms here and there. So really all we're worried about is, does this series converge? Absolutely, because all the terms are positive, or diverge. All right, the next thing we notice is that the numerators and denominators are adding factors in what looks like a factorial fashion. Now, it's not quite factorial because it's not increasing, each factor doesn't increase by 1 each time, but it has that factorial feel because we're adding more and more factors as we add more and more terms. So that's our clue that we probably want to use the ratio test, because if it has that factorial type property, then if we do the ratio of consecutive terms, we should get a lot of cancellation to help us out with evaluating the limit. So we'll use the ratio test here. The next thing we want to do is see what a pattern is for our terms in our numerator and denominator. Notice that in our numerators, then each new factor is 4 more than the previous one. So we're going to have a 4n factor in there. And likewise, in the denominator, each term has a new factor that's increased by 3 over the previous one. So we'll have that 3n fact in the denominator. All right, so then to make things match, and it's probably easier here just to make your series start at 0 rather than 1, just to make these formulas come out to be nice. If I put in 0 for n, I need to get 2 out on top, so that's where the plus 2 is coming from. If I put in 0 for n here, I need to get 5 on bottom, so that's where the plus 5 is coming. So this denominator here represents an arbitrary term in our series. This would be our a sub n piece, if you will. Which means that our numerator needs to be n plus 1, so that means we've plugged in n plus 1 for n here. Now, on bottom, the numerator and the denominator should have n factors, so in the numerator and the denominator should have n plus 1 factors. So when we simplify, the first n factors in the numerator and the denominator on the top should look like the denominator. And then we have additional factors here corresponding to that new factor that was added in both the top and bottom here. All right. So now we notice that there's a nice big lots of things that cancel. All of this cancels. And all we're left with is 4n plus 6 over 3n plus 8. And now this behaves like 4n over 3n as n goes to infinity. So this limit must be 4/3, which is greater than 1. So since the limit turns out to be greater than 1, that means the original series must diverge.